Good afternoon. My name is Ravi Babu, Assistant Professor in Chemistry Department, IARE. Now, I am going to move in first module, that is sampling and reconstruction. Okay. In first module, I am going to sampling and reconstruction topic. In previous class, already we have discussed about the data conversion and data conversion. So, in case of that one, in case of the data conversion, if the bit of the integer bit is going to be increased, then the quantization will be going to be possibility for the net quantering of the quantization is going to be decreases. Because of that one, decreasing of the quantization, so the quantization error also will be decreased. So we have discussed in previous class, that is data conversion part. Okay, data conversion part. Now I am going to moving the next one is sample and reconstruction. Sample and reconstruction. So where it is sample and reconstruction part is coming generally. So see that one. If you see this one is log diagram. Here the continuous time signal is there. Here the continuous time signal is there. Okay, that continuous time signal is going to be given to the AD, analog to digital converter. The digital converter is going to give the output to the input of the computer. Okay, so here discrete time signal is there. Yeah, so it is called as this type of the symbol is called as it is a sample and hold circuit part. It is a sample and hold circuit part. That is here in this place we are going to making the sample and data reconstruction. Sample and data reconstruction. That is at the part of the before the computer we are going to be sampling and data going to be reconstruction the before the computer. So that is the feedback of the sensor. We are going to be taking that part, sample and reconstruction part. So now I am going to for the sample part. Sampling nothing but it is the process in which the continuous time signal is sampled. The continuous time signal is sampled and it is converted into time signal. And it is converted into time signal. That is nothing but here, for example, if you take the continuous time signal, that is analog signal. Okay, that is continuous time signal is nothing but analog signal. This is I am taking. This part is going to be making the sample. That is nothing but like if you take here, it is a peak value now. It is a peak value. So this is peak value. So it is highest value, peak value. Peak value. This is one sample. Peak sample. Peak sample. If I am taking this is 5 volts. This is 5 volts. So it is 5 volts. Next one is another one is I am taking the another sample. Okay. And the sample. It is 4 volts. It is 3 volts. 2 volts. 1 volt. Like this. Like this. Okay. So it is sample. It is sample. So for it is these lines are called as samples. These lines are called as samples. Samples. So this is the process. That is I am going to taking the continuous time signals into sample. Okay, and that part is going to be converted into discrete time signals. Discrete time signals. That is nothing but it is a x of t. That is x of t equal to it is a switch here. Okay. Okay, and x of kt. X of kt. So it is called as a discrete time signal. Okay, it is continuous time signal. It is continuous time signal. Okay, where t is the sample period. Where t is the sample period. That is this part. here this part and this part, this part, this part and these parts. These parts are going to be, I am taking the sample that one. Okay, so I want to getting these samples into discrete time signals. Okay, this is nothing but sample. Next one is reconstruction. That is, in PS1 I am taking the samples now. These samples I am going to convert it into reconstruction part. That is, so it is your x of t equal discrete, that is nothing but it is the computer output. Okay, discrete signal. This one is again going to be with the whole device. That whole device will give the sample signals. So that is nothing but it is a process in which the discrete time data is converted into continuous time data. So it is continuous time. Continuous time data. So it is continuous time and it is discrete time. This is the reconstruction method. That is, sample is coming to us with respect to switch, and continuous will be coming to with respect to whole devices. Okay, it is going to be coming for the whole devices. So what I am saying is, for example, if you take one sinusoidal waveform, it is sinusoidal waveform. Okay, for this one I am going to sample. So it is maximum. For example, if you take 5 volts, it's 5 volts maximum. It is one more, 3 volts like this. Okay, for negative feed, this one again it is 3 volts like this. So it is, second figure is sample process signal. Again, this sample process signal is going to be given to the quantizer. That quantizer is, what is the main function of the quantizer? Quantizer is going to be set the voltage levels. That is nothing but, if this 3 volts now, already I told you this is 3 volts now, it is set is like this, 3 volts. Okay, like this, 3 volts, and it is 3 volts like this. So it is set as 5 volts. So this 5 volts and 3 volts set like this. Okay, that is actually here sampler and quantizer and encoder will be there. Okay, so this is where these total 3 blocks are in analog to digital part, ADC. These are in ADC. Okay, these are in ADC. The sampler input is analog signal. Okay, the sampler input is analog signal. So what is the sampler will do? You see this one. Sampler is nothing but continuous time signals are given to that one, and that part is going to be converted into sample parts. So this is going to be sample part. That is, this one is nothing but this one, sample parts. After that one, quantizer is going to be taken into voltage levels, 5 volts, 3 volts like this. After that one, that 5 volts, 3 volts will be going to be converted into, given to the encoder. Okay, encoder. This encoder is going to be what? It will convert that into zeros, ones like this. Okay, this encoder output is going to be given to the input of the digital computer. This is the part of the ADC. That is nothing but ADC input is from feedback of the output. Your system of feedback of the output. Okay, so here input of the digital controller, another inputs, given input, this feedback of the ADC, this ADC. Okay, and digital computer is going to be given fit to with the which one? DAC. This DAC gives the analog signal that is given to the system. If your system is output is getting exactly, no problem. If not getting, go for the feedback. That feedback is connected to the this ADC. ADC is nothing but this sampler device, like this box. This box. Okay. Okay. This is your total sampling and reconstruction part. Where in case of the sampler, the continuous time signal is going to be converted into discrete time signals, and reconstruction part, in case of the reconstruction part, again the discrete time system is going to be converted into continuous time. That is nothing but the reconstruction is coming to where? The reconstruction is coming to the thing, but it is a part of the DAC. Okay, why? Because it is coming to in case of the reconstruction, the output will be continuous, no? Continuous signal. That is nothing but it is coming to as DAC output. DAC output. So this is your sample and reconstruction components. Okay, sample and reconstruction components. Now this is your sample and reconstruction component. That is, remember, this is discrete time and this is continuous time. Again, finally, you are getting the continuous. This continuous time is going to be given to the process or plant or system. Okay, process or plant or system. Okay, next, coming for that one, sampling. In case of sampling, okay, in case of the sampling, if you see that one, it is your sinusoidal waveform. It is your sinusoidal waveform. Okay, this sinusoidal waveform, here S of t will be there. Here S of t. S of t. That is nothing but we are going to hear sampling. We are going to hear sampling. Okay. So first of all, I am taking the S of t, that is R with magnitudes like this. After that one, this I am going to be applied to this one circuit, for this circuit. This sampling process I am going to apply it to this sinusoidal waveform. That value will be, that is the after applying the sampling process, that is, it is your waveform. It is your waveform. Okay. So if you add these two lines, R lines, it is coming to as sinusoidal waveform. It is coming to as sinusoidal waveform. Okay. After that one, reconstruction. Reconstruction nothing but the sampling output is going to be given to the whole devices. That is, here one sample is came. Again, some of the time it is holding. Okay, holding. That part is nothing but this one. Holding. This part. This is the holding part. Okay, this is a sample part. This is the holding part. Again, what about this one? This is holding. Sample. This is holding. Horizontal is holding. Again, sample. Holding. Like this. Okay, sample and holding. After that one, this is going to be quantizers. Quantizer levels, voltage levels. Quantizer voltage levels. This is your reconstruction part. Reconstruction part. See the equation in sampling what? X of kt. What is this one? This T2 equal to X of t, where t equal to kt. Where t equal to kt. That is nothing but if it is k is the integer. So if it is k value is given to t equal to kt value is given, so it is x of t equal to kt. Otherwise 0. 0 when is 0 coming? At the time of the holding devices. At the time of the hold devices. Okay? At the time of the hold devices. This is nothing but the sampling and reconstruction. Sampling and reconstruction. Okay? Next. This is your sampling and hold devices. Remember that one already in last class I will explain this one is, this is the error signal. Here part. This parts. Okay, this parts. Okay, it is x of t, it is y of t. Okay, so this is input signal. It is okay. It is y of t. Okay, so next coming for the sampling theorem. What do you do? That is nothing but the reconstruction of the original signal is possible if and only if sampling the frequency at least twice of the greater than the maximum frequency components. Maximum frequency components. That is nothing but we are going to be making the reconstruction of the signal. The original signal is going to be reconstructed as twice of the greater than the maximum frequency of the component. That is, f of s is the signal and the maximum value will be twice 2 into f of s. That is, in case of the sampling process, In case of sampling process, we are going to be making the frequency is at least twice greater than the maximum frequency. Twice greater than the maximum frequency. That's why in case of the VA control system is overcome this digital control system. Okay, it is easy to maintain the operations in case of digital control system. Why? Because if having the greater than the maximum frequency. That is F of S equal to greater than or equal to 2FM, and whenever the natural frequency W of S equal to 2 into FM. Okay. Now I am taking the final block diagram of the digital control system where we are to making the sample and reconstruction. That is here it is a continuous time signal. It is given to the switch. That is what is sample. Here it is here. Okay, it is going to be discrete time by using this sample switch. Okay, by using this switch. Okay, by using this switch, it is going to be discrete time signal. That is nothing but it is a sample circuit. So E of t, where this part is a sample circuit. I am going to convert time signal into discrete time signal. That is nothing but it is a sample signal. Okay, so it is given to the feedback to the A to D converter. Okay, here this is a sample circuit. At this part, the continuous signal is going to be converted into discrete time signal. Okay, this discrete time signal is going to be given to the analog digital converter. The digital value is given to the computer. Again, digital computer value is given to the digital DAC. Okay, digital to analog converter. This digital to analog converter is going to the data hold here. So discrete time, okay, data hold signal that is going to be converted into continuous time signals. This is the process I am already explained. Okay, now I am seeing what is the sampler. What is the part? Once again I am saying. Okay, the sampler is obtained from the continuous time signal. Already I explained this one. Okay, it is a discrete time signal by sampling every t time seconds. So here see, at 0 time it is maximum value. At t time, again at t time it is going to be some value. In decreasing, no problem. It is some value. What about this one? This is your 0 value, 0 order. Switch is closed. Here switch is closed. At this point switch is closed. At this point switch is closed. What this between these 2 points? Switch is opened. Okay. So again switch is open here from here to here. Again switch is closed. That value is 2t. Okay, like this. So like this it is going to be processed. That is the input signal is a continuous time signal where it is t greater than 0. The output signal is discrete time signal. That's why here k equal to 0. At the time of it is 0, nothing but it is decreasing like this. This part, the 0 positions. This part. Okay. So both signals have a different identical values in sampling movements. Okay. Not a losses of the procedure, not a time invariant procedure. This is the sampler main advantages. Okay. So now this sampler is going to be given to the A to D converter. Okay. This is a pictorial representation of the sampler of the A to D converter. That is here analog input is given. Okay. So LED lights will be there. Here I am given to the ADCD converter here like this. Here. Okay. So these are the low resistors. Okay. So this is your analog to digital converter. Okay. Next, reconstruction. When the reconstruction is coming, whenever there is a 0 order word, then only the reconstruction will be coming. Okay. So that is nothing but data reconstruction needed to convert digital controller output into a continuous time signal to divide the plant. Okay. What is the reconstruction? Data reconstruction is going to be needed to convert the digital controller output into the continuous time signals. This is the reconstruction of the definition. Okay. Whatever data is going to be coming to there, that is going to be reconstructed to convert the digital computer output into a continuous time signal. It is called as a reconstruction. Okay, reconstruction. So here generally for in case of the reconstruction, the sampling movement will be every time of 0, t, 2t, 3t, 4t like this. Okay, so the sample data reconstruction is 0 order word. Okay, 0 order word. So it is given that discrete time signals are, it will be for k equal to 0 and k equal to 2. So finally what I am saying is a continuous time signal, that is E of t, where it is greater than t equal to 0, then only it is going to be reconstructed. Otherwise, the value of any time, it is going to be equal to the value of e power of kt in the closest of the sampling movement processing. In the closest of the sampling movement processing. So, for seeing this diagram, finally, what I am saying is E of t equal to C. E of t equal to E of 0 into E of t. Okay, E of 0 into E of t. Again, E of 0 is applicable for U of t and U of t period. Sampling period 1 is t value is going to be neglected. That is nothing but before that one. Next one. E of t equal to U into t minus t. So, from here, it is coming from here. Okay, minus after this one 2t. After this one 2t here. 2t. Okay, so the error signal. Okay, the error signal, continuous signal E of t, time signal E of t, continuous signal is the E of t is nothing but E of 0 at the position of 0 position, E of 0 into U of t and U of t minus t. U of t minus t, and before this one. Like this, here the position. This position. Okay, at this position, what is the equation? U of 0 equal to U of t minus t. U of t minus t. Okay, next. What is the next one? This is the next one. When is it occurring? Between t and 2t. Between t and 2t now. So that's why it is E of t equal to U of t capital T equal into, that is U of t minus t. Okay, t minus t minus U of t plus t. Okay, t minus t plus t. This part mottham this. Okay, this one is totally for this one only. Next one is, so continuously we have to writing this one for reconstruction of the 0 order word. Continuously we have to write like this. Okay, next. Coming for this one, 0 order word. The 0 order word is going to be given to the output of the DAC. Okay, DAC, no? So that's why here I am taking as like this. Okay, from here. First I am taking one example. This is the output side section. It is an 8-bit DAC implemented by R by R register network. Okay, R by R register network. This is your digital to analog conversion after the reconstruction. Sorry, before the reconstruction, digital data whole is going to be here before the, after the D to A. Okay, after the D to A. A to D converter. Reconstruction of the 0 to reconstruction for 0 order word. Okay, next one, D to A. Next, see this one. This is what sampler, digital controller, data hold, plant. Okay, and unity feedback they given. This is one of the basics concept. Okay, that is sampler, digital controller, and data hold, plant. Sampler, digital controller, data hold, plant. Remember this. Here data hold is coming. Sorry, here data hold is coming. Here sampler is coming. Okay, sampler is coming. Okay. So, sampler output is given to the data hold. Okay, data hold to the digital computer. Okay, to the digital controller. Okay, just one. See here, sampler and 0 order equations. Okay, so what is the effect of the sampler and hold in a frequency domain? We are seeing sampler and data hold. Between this one, between these two, we are having the digital computer here. No problem. Okay, so E of t input and E of kt, discrete. and where E of t signal. Input signal is there, discrete converted, and input signal is there. Okay, E of t continuous. Next, E of s is the and E of s and E of s. Okay, next, sampler and GRL hold. Okay, see, already in previous PPT we will see this one. Okay, so here sampling is going to be processed. Here sampling is going to be processed, and it is going to be making the quantizer. Okay, quantizer. So the Laplace transform of the E of s equal to E of s into Laplace transform of the E of t. Okay, for that one Z transform, it is Z transform. We will see what is the Z transform in later unit, second module. Okay, and so what is the sample transform for this one? So see this one for 0 position. Okay, 1 of t minus 1 of t minus t. And 1 of t nothing but this one. Okay, 1 of t minus t nothing but it is coming to here. Okay, it is coming to here. Next one is t minus tau. E power of t into 1 minus t by tau minus 1 minus 2 tau. So this one. Here it is. It is. Okay. This is your sampler 0 order word for 0 order word. Sampler for 0 order word circuit. So I am taking the sampler and 0 order word. This is the main equation for here. This is for here. For 0 order word, it is coming to as, remember this one. 1 minus e power of minus t s by 1 minus e power of minus t s by s. Tau is by s. Remember this one. This is for your equation for the sampler for 0 order word. 0 order word. Not a 1 order. It is as a 0 order word. Okay. 0 order word. Next I am going to for the ideal sampler. Ideal sampler. When you are coming to ideal sampler, it is going to be as a impulse pulse signal. Delta of t. Same process. E power of 0, delta of t, e power of t. First, it is first part. Sorry. It is, when it is coming, it is first one 0 part, e power of 0, it is here. It is maximum like this. Okay. E power of t, t minus t. So remember, if you take it is t, it is t equals 0 here. That's why it is coming to t. Here t minus this value. That is nothing but t minus t. T minus t. Okay. Next one is e power of 2t. So it is sequence order sampler. Okay, ideal sampler is sequence order like this. Okay. See this one. Sampler has word first perspective. And taking the first order, first perspective value. Okay. So it is sampler and order. Sampler nothing but here I am getting the parabolic like this. Okay. Like this. Okay. This one I am going to be sample like this. Okay. After that one, holding device. That is nothing but like this. Okay. The data only going to be holding like. Wait for 2 seconds or 1 second. After that, again one sampler is coming. One sampler is coming. So adding these two sampler like this. It is coming like this. No? Okay. This is the way you are going to be sampling for first perspective. Okay. For this one, the equation is and block diagram is E of st greater than or equal to E of st. Okay. Sorry. Yeah, E of st equal there is nothing but E of z for in case of the general word, and output of this one general word is E of s. E of s. So finally, what we have to do in this one is it is E of z equal to k equals 0 to 1. This is the formula as a z transform of the equation. It is coming in next second module. Okay, it is coming in second module. Okay, next remarks of the ideal transformer. What are the remarks you have to take in? Okay, it is not a physical entity. That is nothing but introducing the theoretical convection, linear but non-time invariant, and it is cannot be modeled by the transfer function. Okay, can map the difference E of t and same as this one. Okay, if E of t is the discontinuous signal sampling k of t, then E of t equal to k into okay E of t equal to that's the conjugate of this one. Okay, E of t plus 1 like this it is coming. Okay, this is your already completed sampler or circuit prospection. Next, coming for here, relating to the two perspectives. Relating to the two perspectives here. That is, E of s will be there. E of s will be there. that E of S is going to be converted into E of Z. That is nothing but sampling. Okay, with respect to Z transform. Again, this one, again, where to process to. This E of S is going to be taking the star transform. Star transform. That is nothing but ideal transform. Ideal transform. Okay. After that one, the E of Z is going to be given to the here E of S and E of star. That is ideal sampler output. Star conversion is going to the Z devices. So what about the middle part? What about this middle part? That is E of S equal to the relationship between the Z transform and the star conversion is nothing but it is E star of S equal to E power of Z into where Z equal to E power of Ts. Z equal to E power of Ts. So it is your sample and reconstruction of the digital control system. Okay. So finally, what I am concluding in case of the digital control system. Okay, sampling process is going to be done with sampler. Okay, after that one, the signal is going to be passed through AVIDA. Okay, ADC, unlocked digital computer. Okay, that part is coming on. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.